Hello, calculus fans. Let's say we know the force acting on an object. Then, the acceleration can be found from Newton's second law of motion. So the vector version of this law says that if we know at any particular time a force is acting on the object of mass m, and it produces an acceleration a, then F is equal to mass times acceleration. Notice that in this equation, both F and A are vectors. So as an example, let's say we have an object with mass m, and it moves in a circular path with constant angular velocity omega. So it has position vector r of t equals a cosine omega ti plus a sine omega tj. Now let's note that this is directly related to the standard parameterization of a circle of radius a. Let's find the force acting on the object, and let's show that that force is actually directed towards the origin. This circle will be placed so that it's centered at the origin. Once we have the position function, then we differentiate a couple of times to get the velocity and acceleration vectors. Now let's use Newton's second law of motion. That says that the force is equal to the mass times the acceleration, so we take our acceleration vector and multiply by m. Notice that in this expression I've also factored out a negative omega squared. But notice that now the expression that's in the brackets, that's just r of t. So force is equal to negative m omega squared r of t. So this shows us that the force acts in the direction that's opposite to the radius vector, and thus it points towards the origin. Here's a picture. Imagine that you have an object at the end of a rope and you spin around. You're always pulling towards the center. A force that pulls towards the center of a circle is called a centripetal force. That's a center-seeking force. Okay, that's all for now.